Right. Arithmetic sequence. Really useful in many ways. You've got to think about how you could model real-life situation with arithmetic sequence. Now, notice that what I have actually drawn out here. I've got 1, and then 3, and then 5, and then 7. Here I've got 5, 9, and 13. You've got to think about how you observe pattern. Sequences are always patterned. Alright? So, by the end of the lesson, you should be able to define an arithmetic sequence recursively and in terms of difference. You should be able to list terms of an arithmetic sequence given a rule. You should be able to write a recursive rule for an arithmetic sequence given terms. Able to write general or the explicit rule for an arithmetic sequence and make a connection to linear relationship. So here on the board, I wrote down the recursive rule and general rule. We will talk about both of them a little bit later. You should be able to find the nth term of an arithmetic sequence. And then, given two terms of an arithmetic sequence, find the common difference, first term and then the rule. Then you should be able to verify whether value is part of an arithmetic sequence. Alright? Now, let's recall what I talked to you yesterday. I showed you yesterday. So yesterday I give you a series of numbers 3, 6, 9, 12, continuing just with a break to 21, 24, and then it continues, go on and on and on. So I describe it as start with the number 3, add 3, and then continue with this process. Or algebraically, I could write down Tn plus 1 equals to Tn plus 3, T1 equals 3. So Tn is any term in the series, in the sequence, not series. I'll talk about series a little bit later, not this lesson, other lesson. So starting from here, this is T1, if you cannot remember, T2, so on and so forth until you get to Tn. So if I've got Tn, any term, Tn, the previous term will be Tn minus 1, dot, dot, dot. Let's go going backwards. And then Tn plus 1 is the subsequent term. Alright? So you've got to bear in mind, we are representing how we are finding Tn plus 1 with the process of adding or geometric sequence will be multiplying with a constant. Alright? So let's think about what the difference is, how we could actually work out the common difference. So if you look at the sequence that I gave you, a sequence is said to be arithmetic where there exists a first common difference d between the terms. So if you look at this sequence I have on the board, the difference is plus 3, correct? So from term 1 to term 2, I added 3. Term 2 to term 3, I added another 3. Term 3 to term 4, I added another 3. And therefore, algebraically, I could say Tn plus 1 equals to Tn plus 3. Now, if you don't specify T1, how on earth are you going to specify the sequence? You don't know what the start is. Correct? So you must always specify T1 in terms of any sequences, especially talking about the recursive rule. For the recursive rule, which is this, you must always indicate what T1 is. So T1 plus D, that's a first common difference, and A is the first term. Alright? So this is important, this box is important. If you want, write that down please. The recursive rule is Tn plus 1 equals to Tn plus D, and T1 equals to A. Alright? So D is the first common difference and A is the first term. That will always be the same, whether we use explicit rule or whether we use recurrence rule. Alright, I am going to move on to the next slide. Everyone ready? Okay. So, now if we look at Tn plus 1 equals to Tn minus 2, T1 equals to 19, how would you describe this rule? Remember I said when you describe a rule for a sequence, you must always state the starting point. So start with the number 19. The subsequent number is the previous number, take away 2. All right, and the process go on. So in this case, if you're given that, this I will let you describe it yourself. But you must always state starting point, starting number, and the mathematical process. All right? So what then will be T2? 17. So can you therefore write the first 5 terms of the sequence? Pretty straightforward. Now, this is the basic, the introduction. Eventually, you'll be using sequences to model real-life situation and to come up with certain solution. All right? That's a point that we really need to use your class pad in many ways. Now, can you spend the next probably about 5 minutes or less just working on exercise 1 and 2, please? The sheet that I've given you. So you need to think about whether you could generate the first 5 terms of the recursive sequence, whether you could determine the recursive rule given the terms. I will discuss exercise 2, question 3 in a few minutes. All right? So just to practice what I've taught you. Yeah. Which one? Sorry. Oh, 1 and 3 are the same. Oh, just it doesn't matter. I know why. I did a copy and paste with 1 and 3. I wanted to change the number, but it doesn't matter. If it is the same, just ignore one of them. You get the general gist of the question anyway. All right, try to work on question 2, maybe 2A, please. Now, 2A, what is the process? What would you do with 2A? Tn plus 1 equals to Tn. What is the difference? Plus 3. All right, so T1 is then equal to 15, thank you. So that's what you need to recognize. What is the difference and what is T1? All right, skip to question 3. The rest you can finish at home. Now, question 3. You've got algebraic expression. You've got x minus 1, x plus 2, x plus 5, x plus 8. Can you work out the common difference between terms? Thank you. Plus 3, plus 3. So therefore, we are still using the same. Tn plus 1 equals to Tn plus 3. And this time, T1 is actually equals to x minus 1. So you can specify x. You can change the x because x is unknown. Alright? However, you can see that in both situations, we've got Tn plus 3. If you don't specify T1, what's going to happen? You actually don't know what the sequence is. Right? So think about it. Sequence, you must, for recursive rule, you must always state your first number. Alright, now I'm going to derive the general rule or the explicit rule of the nth term. So I use general rule and explicit rule interchangeably. So make sure that you understand what a general rule is and what an explicit rule is. Now, I've given you Tn plus 1 equals to Tn minus 2, T1 equals to 19. Can you therefore complete the table, please, on that table, on your book. All right. So now in this case, I've got Tn plus 1 equals to Tn minus 2. T1 equals to 19. All right. So you know, yep.
Do you have to say Tn plus 1 or can you say Tn and then Tn minus 1?
Yes, you can do that. But the general convention will be Tn plus 1.
Okay.
All right. Because you want the subsequent terms. You can use Tn equals to Tn minus 1 minus 2.
Yeah,
you can do that. But all right. So the next one will be 17. And keep going. You will have that. Correct? Yeah? Do you agree with what I'm doing now?
Yeah.
So here, when we jump to the term 3, 2 is subtracted. I've revealed the answer twice because, see, in term 3 here, all right, you have already taken away 2 once, twice. Correct? Agree? What about when I jump to the 5th term? 4 times? 10th term? And what about nth term? Alright, so can you therefore derive the general rule?
Yeah.
How? So what are we going to do in this case? We are going to state that Tn is actually 19. So whichever term is 19 plus n minus 1 times minus 2. Now, very clear, I want you to put in a bracket for minus 2. Okay? Yesterday I was watching a webinar on waste exam, and the examiners was talking about sequences for year 12 applications. They do the same thing as well, and about maybe 80% of people who did not use the bracket and subsequently made lots of mistakes. So always remember, when you put in a D, make sure that you have a bracket, and make sure that if you, especially it's a negative number, so that you know that this is multiplied in. Alright, so 19 plus n minus 1. So term number 2 is 2 minus 1, which is 1. Correct? 1 times minus 2. So 19 minus 2 is 17. Can you see the progression now? So you can here expand it and rewrite your general rule as Tn equals to 21 minus 2n. Alright. Here, with a general rule, you do not have to specify term 1 because it's built in. It's built in this equation already, correct? Agree? Because 19 is in that. That's the term number 1, and that is your difference. Right? So in here, you're building in term 1, which is A, and this is the difference. Alright. What I'm going to do is to show you the general rule. So the general rule of the nth term of an arithmetic sequence is therefore Tn equals to a plus n minus 1 times d. Alright? Where d is the first common difference and a is the first term. So it's actually inbuilt. Here, we always use a as the first term, d as the first common difference. And n is the position of the term. Alright? So it could be T4, T5, or T6, or whatever. So now, using the explicit formula, Tn equals to 21 minus 2n, can you determine the 100th term in the sequence? Pretty straightforward. Just substitute n in. So Tn, T100, T100 is therefore 21 minus 2 times 100, which is 21 minus 200, which is minus 179. Alright? Now, what I'm going to do is use this example to show you how to use your class pad. So writing this down, Tn equals to 21 minus 2, hang on. What I'll do is write down 19 plus n minus 1 times minus 2, or equals to 21 minus 2n. Alright? Here, if you want to generate the first few, let's generate the first 3 numbers of the sequence. With this, I know it's 19, 17, and 15. Correct? Using the explicit rule, if n is 1, 1 minus 1 is 0. Therefore, T1 is 19. N is 2, 2 minus 1 is 2 minus 1 is 1. 1 times minus 2 is minus 2, so it's 17 and 15 and so on and so forth. Both rules will give you the same sequence. Alright, let's actually do your exercise 3 first. Very quickly do your exercise 3, then I'll show you how to use your class pad. I'll give you a couple of minutes to do exercise 3.
So,
Yep.
you have to expand that into like 21 minus 2.
Yeah, I would prefer you to expand.
Oh, yes. I was actually.
Avoid using your calculator because there will be, pretty sure there will be question in the exam without calculator. All right, I'll give you a couple more minutes to finish. Oh, actually, no, I think we should stop now because I want to show you how to use your class pad. All right, let's stop for a minute. The exercise you can continue doing it at home. Go to your class pad, please. All right. Now, if you go to menu, what you need to do is go across to sequence. Alright? You need to be able to use a sequence function in your class pad. So when you tap on sequence, it will come up with this. Note that there's recursive and the explicit rule. Recursive, you're going to specify T1. Explicit, you do not have to. Alright, note, if you go to recursive, there are many types of recursive rule. So if you tap, you just tap on type. Alright, tap on type. We are going only to use the first two, either A0 or A1. I will tell you the situation when we need to use A0 eventually. At this stage, we are going to use A1 first. Alright, we're going to use A1, so always just tap on that. And you can see that all this has changed to A1, B1, and C1. So in your class pad, it uses A instead of T rather than terms. It doesn't really matter. Now, so start off with that. How do we input that function information in Tn minus 2? This here, N, AN, will give you whether you put in AN, BN, CN, or N. So what you need to do is, that will be AN minus 2. And then A1 is 19. Then you tap on that little box, click that, and upper leftmost, that will give you the list. It will generate your sequence. Right, it gives you the N, and it gives you AN. Now, if you use this for the first time, it will probably give you 5 numbers or 6 numbers only. What you need to do is go to this button here, second last button, where you got plus X, X and Y with the arrows, with 2 arrows. Tap on that. You want it to go up to about 50 so that you can see the 50. Up here, this little button here, and you can think about the sequence. The start point must always be 1, not 0. Alright? It has to be 1. Because it's type A1. You must be A1. Alright? Alright? So once you've got there, you can click OK, and you can scroll down to see the numbers. Alright? Like I wanted you to find 100, so you can go to the sequence if you do not have an explicit rule. You go up and get the table to generate up to 100, click OK, and then go all the way down. It's 179. Now, make sure that you don't have too many ends there, because sometimes some of the more complicated sequence, it will take a while to generate. So leave it at about 50 unless you're required to do anything more than that. I'll leave it at about 50. Alright, that is a recursive rule. With your explicit rule, there is no need to say whether it's AN or A0. Alright? Now, if you have 2 different rules, what you need to do is go in, tap on this, and it will clear itself. So go back up. Here, you need to put in 19. When you input, you can either do the first one or the second one. It doesn't really matter. I will show you plus a bracket n. This is n here. N minus 1 times minus 2. Alright? I will input it this way. It's fine if you want to expand it. It really doesn't matter. So, and tap execute, and then generate. Execute to make sure that this is checked and make sure that's correct. Alright? And you can see that you get the same, exactly the same sequence. Yep.
How do you write N?
You go on
And up here, little button, actually, let's go back up here. N is here, that button there. That's N. Alright, explicit doesn't have any type. You don't have to worry about the type. If you tap on type, it will not show anything. It's blanked out. Alright, you can only do N. See, even if AN, you can only do N, that's all. Alright. Now, this is introduction to sequences on your class pad. You'll be using it quite a lot the next couple of weeks. Alright. Are you all happy with it?
Yeah.
Good. Let's go back to lesson. Alright. Next. Just a summary. I've shown you the summary of I've shown you how to write a recursive rule from a sequence. And from the recursive rule, or even from the sequence itself, you should be able to generate the general rule. So the main thing for you to know is recursive rule, you must always specify the first term. Alright, granted in the exam or in the test, sometimes third or the fourth term is given, you're going to find term number 1. That's problem solving for you. Alright, but when we state recursive rule, always state T1. General rule, we don't need to state T1 because T1 is already inbuilt in that general rule. Alright, so D is the first common difference, same for both, and A is the first term. Any question before I move on? Alright, let's think about the next part, which is finding the rules for from two terms. First, let's think about finding the equation of the straight line which passes through points 8, 3, 2 and 15, 53. How would you do that? Yes?
Find the gradient first.
Find the gradient first. Very good. So let's do it. How do you find the gradient? All right, and
15 subtract 8.
all right. So therefore, we know m is 3. Right? We can use y minus y1 equals to m, x minus x1 to work out the equation. So therefore, y minus 32 equals to m, which is 3, x minus x1, which is 8. So therefore, y minus 32 equals to 3x minus 24, y equals to 3x plus 11. All right? Now, so what can you see from there? What is actually the
Wait, are you sure it's
y-intercept? Sorry?
Are you sure it's 11?
Oh, no, it's not. I'm not sure. 32.
Is it 8?
No, it's 8. It is 8. Sorry. What am I thinking? I don't know what I'm thinking.
Neither.
Yep, it's 8. I'm not sure it's 11. All right. So it is 3x plus 8. What is, in that case, what is the 8? That's the y-intercept, correct? Very good. So this is the y-intercept. And that is the gradient. All right? Now, hold your thoughts there. Let's do the next question. All right. Now, if the 8th term of a sequence is 32 and the 15th term is 53, can you state the general rule and recursive rule of this arithmetic sequence? Can you find a common difference? Can you?
It's like
So watch. So you know T8 is 32. And then it keeps going up until T15 is 53. Correct? Now, isn't this the difference? Can you see that what we're going to do in this case is we are bringing it back to finding the gradient. The terms, y is actually the terms, T15 and T8,
oh my god, this is
T15 and T8, and then n is 15 and 8. Correct? So therefore, what we're going to do is
No, wait, it's not.
use
It
D
has to be 1.
is 53 minus 32 and 15 minus 8, which is 21 over 7, therefore 3. All right? So you could actually use your gradient formula to find your common difference, where the terms are the y and the n is the x. Yeah? Got it? Now, here, let's think about finding using the common difference to find the general formula, and the general formula to find a. We know that T8 equals to 32. Yeah? We don't know a, but we know n is 8, and we know Tn is 32, and we know d is 3. So if using Tn equals to a plus n minus 1 times d. Alright, so Tn 32 will then be equals to a plus 8 minus 1 times 3. Do you agree? So 32 equals to a plus 24. A is therefore 8. We found that. So therefore we can write down Tn plus 1 equals to Tn plus 3. T1 equals to 8. And Tn...
It is, it's 11.
Sorry?
Wait, so isn't it 11?
7.
Because it's not the y-intercept, it's when x equals...
Oh, hang on, it's
Yeah.
21, my fault. I know where the 11 came from just now. That is, I was multiplying by 8, my fault.
That's what you were thinking.
That was what I was thinking just now. So I should be multiplying by 721, so therefore A is 11. Oops. All right, so therefore T1 is 11. All right, so I'm going to show you the difference as well. So Tn
Someone's gonna run.
equals to A, which is 11,
Oh, no, it's...
plus n minus 1 times 3. Correct? Or expanding it, going up there, Tn equals to 11 plus 3n minus 3, therefore is 8 plus 3n. Now, can you see that 8 plus 3n in relation to that? Yeah? You can see that? So, what I'm going to suggest to you is, when you've got a general rule, this here, when that number, the constant, is actually the y-intercept, or actually is T0. We don't specify that. Yeah? Do you understand where I'm coming from?
Yeah.
So that's actually T0. We don't normally specify it. We, looking at sequence, we start off from T1. Yeah. So in terms of, if you draw a graph, I'll talk to you about graph a little bit later. You know that y equals to mx plus 3. M is 3, x is plus 8, sorry. So that would be your straight line. Y equals to mx plus 3. 3x plus 8. Alright, that's what we found. Now this is your y and x. When we are plotting sequence, y and x, we don't start from the 0, we start from 1, 2, 3, and it's actually just a dot. So the difference between plotting sequence, which is, this is now Tn, and this is now n. It's discrete. So difference between linear equation is a straight line. It passes through the y-axis. For sequence, unless we specify T0, we don't normally plot the T0. We just plot it as points. All right. Now exercise 4. Before exercise 4, you do exercise 4. I'm just going to sum up what I've taught you today. So you should know what a recursive rule is, as you should know what a general and explicit rule is. All right? I've defined to you what an arithmetic sequence is. It's a sequence with a common difference. And you must always specify the start of the sequence. I'm going to stop now. There should be exercises from Sadler as well for you to do.